Fellow students, I greet you all. I hope you're still on the right spirit. We're still continuing with a Euclidean Geometry. It's a grade 11, the very same question paper, November DBE 2015. The question that we are faced with is question number 10, and question number 10 is given in this form. In the diagram, here we are told that, O is the center of a cycle. A, B, C are points on the circumference of the cycle. Chord AC and BC and radii AO, BO, CO are drawn. And then we are told that an angle A is equal to X and an angle B is equal to Y. Okay, using this information given to us, we will go directly to the question that is posed to us. We are required to determine the size of O1 in terms of X. All right, let us go back to the diagram. In this diagram, I know that AO, BO, and CO are all ready. What does that mean? It means that all of these sides are equal. Okay, what is it that I know also? I know the angle for this one and the angle for this one. The fact that I'm working with the triangle that has equal sides, it makes this angle to be equal to X. So here, my angle A is equal to C1, they all equal to X. Why am I saying so? The reason behind that is that it's angles, angles opposites equal sides. And then you can mention those sides. It is AO, which is equal to CO. So A and C1, they both equal to X. The reason being is because are angles that are opposing equal side. So this angle opposes this side and this angle opposes this side. So angle oppose equal side gives you equal angles. Moving forward, here this is a triangle. Triangle COB. In a triangle COB, the very same thing applied. Triangle, these two sides are equal. It makes this one also to be equal to Y. All right. Here, I said angle B is equal to angle C2 is equal to Y. The reason is the same, angle of equal sides. Which sides that are equal? It's BO is equal to CO. All right. What is the question given to me? I'm required to determine the size of O1. All right. How do I get O1 knowing C1 and angle A? That one is easy. Okay, it's 10.1.1. To get that one, O1 is equal to angle C1 plus angle A. The reason behind that is it is an exterior angle of a triangle. We know that when we have a triangle, this one, this angle, okay, suppose A, it's B, and it's C, C1 and C2. C1 will be equal to a summation of A and B. The reason is because it's an exterior angle of a triangle. So this is the theorem, or this is the result that we use to deduce that these two are equal. So as the result, angle O1 is equal to C1 is X plus X, which makes angle O1 to be equal to 2X. All right. Moving forward, hence, once you see the term hence, that implies that using the information previously, you have to use that information to solve the following question. So they say here, hence prove the theorem that states that the angle subtended by an arc at the center is equal to 2 times, or is equal to twice the angle subtended by the same arc at the circumference. That is, triangle AOB is equal to triangle is 2 times triangle ACB. All right. In this case, I will just summarize this theorem. It's the theorem that says that an angle at the center is 2 times an angle at the circumference. How do we prove that? By using this information. Look carefully. I said O2 is equal to 2x. It's an exterior angle of a triangle. Similarly, by saying similarly, I'm referring to what I did previously. So I'll just say similarly, angle O2 is equal to 2y. Why am I saying 2y? It's because this is an exterior angle of this triangle. So an exterior angle is equal to summation of the angles opposing that exterior angle. So in this case, it is y plus y, which gives us 2y. So that's why I said similar, meaning by applying the very same thing, I get that angle O2 is equal to 2y. I can just write that it's an exterior angle of triangle method. All right. So from here, I am required to find AOB. Okay, before I go for AOB, now I know the angle of X of C1 and the angle of C2. To get C is equal to C1 plus C2, of which is X plus Y. There is no reason for that because it's something that has already been proven. Moving forward, now I want to find AOB. So my AOB is equal to, it's O1 plus O2. And I know O1 is equal to 2x plus I know O2 is equal to 2y, which makes the result be 2 into, I can factor out 2 because 2 is here and 2 is also here, and they are being separated by the operation plus. So if I factor out 2, I'm left with x plus y. So if you can look carefully here, therefore, triangle A or an angle AOB is equal to 2 times, you see, I said x plus y is equal to what? Is equal to c. So it's 2 times angle c, because angle c is equal to x plus y. So we did manage to prove that an angle at the center is 2 times an angle at the circumference. I hope this video was helpful. Please don't forget to subscribe and please share this journey with me while I'm still giving you more proofs on Euclidean geometry. Stay tuned. Thank you.